This portion is called is the present value interest factor of annuity. So this I can calculate from the table also, and we can calculate it from the equation. From the formula also, putting the value we can calculate easily. So any formula I can show from the formula and from the calculator, from the table, I will show in the next class. Thank you so much for watching my video. Please go through my video thoroughly, because these are the very conceptual things. These are the conceptual things I have shown you in details. Hi, good afternoon everyone. Welcome back to my academic video of financial management. Today I am going to discuss about a very important topic like present value of annuity. In the previous video I have discussed about the future value of annuity. Today I will be discussing about the present value of annuity. And remember, we are just considering the ordinary annuity, not the annuity due. Ordinary annuity, because considering that the payment of receipt cash flow is occurring at the end of the every year. So it will be ordinary annuity. At the end of the period, actually, it may be monthly. I explained also how if it is monthly, quarterly, semi-annually, also what will be the situation. That also I have shown you. So today I am going to explain the present value of annuity in case of ordinary annuity. Annuity is yearly. Annually, here the term will be discounted because it is a discounted. Annually discounted because the matter is the present value of money. In case of present value of money is R is equal to discounting period. Discounting rate. Suppose R is equal to discounted. N is the number of annuity. A is the amount of annuity. Suppose I am showing by a timeline. Suppose you are supposed to get a 3 cash inflow of 1,000 rupees after every year. This is 0 year. At the end of first year, second year, third year. So, what will be the cash flow? Cash flow will be 1,000 rupees. That is the annuity will be. I told you the annuity is the fixed amount of cash flow in regular interval of time. Regular interval is 1 year. Every 1 year, there will be a cash flow of 1,000 rupees. There will be 3 cash flow. First cash flow will be at the end of first year. Second cash flow will be at the end of second year. Third cash flow will be at the end of third year. And after third year, after this payment, at the same time you will get back the money. So suppose you are supposed to get this, you are going to get 3 amount of cash flow in this way. So what will be the present value of this cash flow? So in the you see how much it will be. It will be discounted. It will be discounted for 1 year. So present value of single amount. What is the present value of single amount? Here you see there is a 3 single amount. We will first calculate the present value of the 3 single amount, and then we will add and we will find the present value of the 3 annuity. So this, if we consider this amount, this single amount, it will be discounted for 1 year. So 1,000 into 1 by 1.1 to the power 1. It will be discounted for 1 year. So what will be the value you see? 1 by 1.1 because e to the power 1 is equal to 9091. It will be 1000 into 0.9091. What will be the value? 909.1. This, the present value of this first 1000 rupees will be, first cash flow will be 909. What will be the present value of the second cash flow? You can calculate here. It will be 1000 into 1 by 1.1 to the power 2. 0.9091, 0.9091 to the power 2 is equal to, what will be? 1000 into 82, 0.8264 into 826.46, this one. And the third one discounted for how many years? It has been discounted for 1 year, it has been discounted for 2 years, and it has been discounted for 3 years. What will be the value? You see, 1000 into 1 by 1.1 to the power 3. Now the value I can easily calculate. 0.9091 to the power 3 is equal to 1000 into 0.7513. So rupees 751.34. So these are the three results I have got. Then easily after adding this, with addition of this 3 amount, I can get the present value of this 3 annuity. How much will be the present value of the annuity? You can see here, 909.1 plus 826.46 plus 751.34. So here 909.1 by 826.46, 751.34 is equal to 21862.186.9. 19 is the present value of this future 3 cash flow. Now I am getting the formula. So from here we have to put a generalized formula. How can we put a generalized formula here? You can see there is a 3 cash flow of 1000 rupees for next 3 years. Normal annuity, not the annuity due. Cash flow has been occurred at the end of the year. The present value of each year I have calculated. Present value of each cash flow I have calculated. The first one, second one, and first one is this much, second one is this much, third one is this much, and the summation of this is equal to 2186.9. So this way I have, from the timeline, I have calculated the present value of the 3 future cash flows. Now I have to find out the generalized formula like the future value of cash flow. So here, suppose this one, the first amount, we can present value of annuity. For this first value will be 1000 into 1 by 1 plus 0.1 to the power 1 plus second one will be 1000 into 1 by 1 plus 0.1, which is 0.1 to the power 2. Third one is equal to 1 by 1 plus 0.1 to the power 3. This is the 3 cash flow. If we generalize it to find a formula, suppose annuity is equal to A, discount rate is equal to R, and the number of annuity is equal to number of annuity and 3n. Number of annuity. Present value of annuity is equal to, here it is A is equal to 1 by 1 plus R to the power 1. A into 1 by 1 plus R to the power 2 plus A into 1 by 1 plus R to the power 3. This is the formula. Now generalized formula will be generalized formula will be PVA is equal to A into 1 plus R to the power 1, A into 1 by 1 plus R to the power 2, A into 1 by 1 plus R to the power 3 plus dot 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 A into 1 by 1 plus R to the power, we can put the power below there, just you put the power here, 3, 2, put the power in the denominator, n minus 1, and it will be A into 1 by 1 plus R to the power n. Now, so the formula will be like this: PVA, present value of annuity, is equal to A into 1 by 1 plus R to the power 1, A into 1 by R to the power 2, just dot 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 dot, A into 1 by 1 plus R to the power n minus 1, A into 1 by 1 plus R to the power n. This is equation 1. 1 multiplied. Equation 1 into equation 1 into 1 plus R in both sides. In left side and right side, we will multiply by 1 plus R. So what will be the result? You see, present value of annuity into 1 plus R is equal to A into, I am showing you something, 1 by 1 plus R to the power 1. So actually 1 by 1 plus R to the power minus 1 plus 1. So here you see 1 by 1 plus R into 1 plus R. So it will be cancelled. So the result will be A here. The next one will be actually if the power is a denominator, then the x by 1 by x by x square is equal to 1 by x to square 2 minus 1, like this. Same, x to the power 1 by x to the power 2. Then 1 by x to the power 2 minus 1. Same way, it will be this way. It will be 1 by 1 minus 1 is equal to, see, this to the power 0 is equal to 1a. This will be a into 1 by 1 plus r to the power 2 minus 1, because I am multiplying by 1 plus r. 1 plus r will be in the numerator. So it will be 1 plus r by 1 plus r to the power 2 is equal to 1 plus r to the power 1. Dot 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 dot. It will be a into 1 by 1 plus r to the power n minus 1. Here it will be, here you see, here it will be another minus 1, then minus 2. Then it will be a into 1 by 1 plus r to the power n minus 1. So you see, what is the previous is 1 by r to the power n minus 1. The previous one will be 1 by r to the power n minus 2. So 1 by r to the power n minus 2. Now subtracting equation, this is equation 2. It's very important equation. Subtracting equation 2 minus equation 1. That is, we will be subtracting equation 1 from equation 2. So PVA into 1 plus R minus PVA. This is 1. Left side, this is PVA. PVA into 1 plus R. This one you see, very interesting. This one will be cancelled by this one. Because this one minus this one, this will be minus figure. This one will be next one, this one. Because you see, the next one will be 1 by 1 plus r to the power 3. When it will be multiplied by 1 plus r to the power r, then the next figure will be 1 by 1 plus r to the power 3. When it will be multiplied by 1 plus r, then it will be, here it will be 1 plus, what will be the figure? It will be 1 by 1 plus r to the power 2. So in this way, every figure will be multiplied by the next figure, you see. So here will be, this figure will be 1 by 1 plus r to the power 2, my 3 minus 1. So this will be cancelled by this one will be cancelled by this one. Same way, this one will be cancelled by this one, 1 by 1 plus r to the power n minus 1, 1 by 1 plus r to the power minus. What will be the previous value here? 1 by 1 plus r to the power n minus 2. Then if I multiply this 1 by 1 plus, this figure will be 1 by 1 plus r to the power n minus a into n minus 2. If I multiply it by 1 plus r, then it will be 1 by minus 1, it will be 1 by 1 plus r to the power n minus 3. So the next one is n minus 1, n minus 2, minus 1, n minus 3. So in this way, you see that this figure is n minus 1. So n minus 1 will be multiplied this one. You see n minus 1, the previous figure is n minus 1, n minus 1 will be n minus 2. So this one, if it is calculated, it is multiplied by n minus 2. When n minus 3, this will be n minus 3. Then it will be n minus 2. So this way, this one will be multiplied by, so this one will be cancelled by this one will be cancelled by previous one. So this way, the previous one is n minus 2. The previous one, what will be the previous one? 1 by a into 1 by r plus r to the power n minus 2. So this n minus 2 will be cancelled by this one. Same way, everything will be cancelled. So we will find only the remaining, the number will be, here you will see this one will not be cancelled and this one will not be cancelled. So what will be the result after subtracting? We get 2 minus 1. 2 is how much? 2 is a minus, 2 is a minus a into 2 minus 1, a into 1 by 1 plus r to the power n. This is the result. So here we can calculate now is equal to, or PVA plus PVA into r into minus PVA. So here you see, I take common 1 minus, what is the result? 1 minus 1 by 1 plus r to the power n. This is the result I have got. Here you see. This one will be cancelled, this one will be cancelled. So if we divide both sides by r, this r will be cancelled. And what will be the result? You see, so we can put it here. If divide both sides by r, divide both sides by r. So PVA r by r is equal to PVA. Present value of annuity will be, this is very interesting, a into 1 minus 1 by 1 plus r to the power n whole by r. This is the formula, and this portion is called the future present value interest factor of annuity. So what is the formula we have got here? The formula is like that. the formula of present value interest factor of annuity is the formula of present value formula. We have derived the formula. I have shown you. That is for your better understanding and conceptual clarity. I have shown you in a detailed way. For better understanding, you will find the formula for present value of annuity is equal to, what will be the annuity? You see, what will be the present value of annuity? Is equal to A into 1 minus 1 by 1 plus r to the power n whole divided by r. This portion is called the present value interest factor of annuity. This portion is called the present value interest factor of annuity. So this I can calculate from the table also, and we can calculate it from the equation. From the formula also, putting the value we can calculate easily. So I will show in the next class. Thank you so much for watching my video. Please go through my video thoroughly, because these are the very conceptual things. These are the conceptual things I have shown you in details. In details, you see first step, second step, third step. The way from the timeline, I have got the formula, type of formula, putting the value. Then I have got a generalized formula here. I have got the generalized formula. Putting the n, I have got the generalized formula. And this is the equation 1. Now multiplying the equation 1 by 1 plus r, I have got this one. And multiplying it, I have got this one. Then when we will subtract this one, subtract this 2 minus 1, you can easily see how this will be cancelled. Only two items will be remaining, this one and this one. So we are subtracting 2 from 1, so 1 from 2. So the remaining will be a minus a into 1 by 1 plus r to the power n. So a minus a into 1 by 1 plus r to the power n. So taking a into bracket, I get a into 1 minus 1 by 1 plus r to the power n. Dividing both sides by r, I get PVA is equal to, because in the left side also PVA minus PVA r minus PVA. PVA and PVA will be cancelled. PVA into r. PVA into r, if I divide by r, it will be PVA, and if I divide by r, a into 1 by 1 plus r to the power n whole by r. This is I have shown here. This I have shown here. This is the formula. For better understanding, you see, this is the formula. Clean formula, you see, PVA, the formula for present value of annuity. I have derived it from the timeline, and I have shown you. Tomorrow, in the next class, I will show you how to put the values from the present value interest factor annuity table, and how you can calculate by using the formulas. Thank you so much for watching my video. Bye, take care, have a nice time.